Welcome to this my video lecture, and here we are going to discuss about how we can visualize complex function. Visualization of a complex function in MATLAB can be done in the several ways depending on the type of the function and the information you want to convey. Here we will discuss some common techniques for the visualizing complex function. In the command window where you can see my cursor is at the prompt sign, we are using here anonymous function to write complex function. Okay, and say that f is a function of one variable. Complex it will be always one variable function and can be defined as in this way. Say it is z square. Okay, z square, then plus 1 iota. 1 into I, this is the iota, and product z. Then you can use here semicolon to suppress the statement, and if you want to comment, then you can use the comment here also. Define complex function, okay, using anonymous function. So here we are using anonymous function. Then we need grid x and y, the real part and imaginary part of the complex variable. Okay, that can be done by using the mesh grid function. X comma y is equal to, we have is mesh grid, and put here inside the interval for x and y both -2 colon 0.1 colon 2. This is for x, then comma -2 colon 0.1 colon 2, and press it, then enter. After that we need the complex variable. Z is equal to, I have is x plus 1 iota and product y. So in this way you can do, enter the complex variable also. Okay, then enter. After that we need to pass this z variable corresponding to this dimension for x and y, both are -2 to 2. Okay, and when you we need to compute the values of f for this mesh grid and the domain, okay, with the help of z variable. So z variable real part will be from -2 to 2, and imaginary part is also from -2 to 2. Okay, so this will be say w is equal to fz. This will compute the values of function. Compute the values of f function for the given domain. Okay, and then enter. Now we can easily use the surface function to plot the graph. We are using surface function. So first we have x, then y, then we are using for real part, real of w. Okay, real part of w. Along with we can use the grid on, and box on. Okay, box on, then enter. So here we have, this is the graph for the function, and you can see on the horizontal line, this is the real part and the other side is imaginary part, and on the vertical side you can see this is the real part of function. Okay, and also the most important thing is when you will left click, and you can rotate this diagram in any direction. Okay, so in this way, by using this statement, we can easily plot the complex function by using MATLAB. If you need the imaginary part, then you can use here, this is the imaginary part of imaginary, okay, of w, means the complex function. Okay, and the imaginary part of the function will display it in this diagram like in this way. So real part and imaginary part on the horizontal line you can see the same, and the graph is corresponding to the imaginary part of the function. Okay, you can check it very carefully. Now all these things we will do in the using script file. This will save our time, and all type of the different type of the common techniques and the method are there. Okay, so here you can see we have the same statement I put here. F is equal to z square plus iota z, and these are the same mesh grid. Okay, and here is the w is equal to fz. This will compute the function values. Then after we are plotting here real and imaginary parts of the function. So this is the first subplot. Okay, this is the first subplot, and you can see this statement, and by using title, x label, y label, and z label, then after we have the box on. These statements are used for the first graph, okay, which is real of w. And this is the second subplot. This is the second subplot, you can see here, but in the second subplot we are using the imaginary part of w, and the other statements you can see will remain same. Okay, and title is imaginary part of fz. To run this script file in your MATLAB, just you need to enter Control and enter. And you can see in the single graph we have a real part. This is the first image, and this is the second image of the imaginary part of fz. And in the first image we can see the real part of fz. Okay, and if you want to rotate in any direction, you can rotate these diagrams at 360 degree. Okay, so here this is the real part of z, and this is the imaginary part of z, and here on the vertical line you can see real part of fz, and in the second diagram you can see the imaginary part of z, and here we have the real part of z, and on the vertical line we have imaginary part of z. Okay, so here you can see this is the real part, and this is the imaginary part, and this is the imaginary part of the function. So we can display both the functions in the single image. Now here we have the magnitude and phase plot. Okay, so here you can see for the magnitude we are using surface x, y, absolute value of z, absolute value of function w. Okay, and then the other statement are same. Here we will put the magnitude of fz, this is the title, then x label, y label, z label, and box on, box, grid on. And in the second we are using here phase plot, and for the phase plot we are taking here angle z. Okay, and then after we have the title, x label, y label, z label, box on, grid on. And when you want to execute this shell, okay, for these two graphs, control and enter, you will see we have two images are there. So first see this graph. Okay, and note this graph very carefully. This is the surface. Here is we have is the imaginary part, and in this direction we have the real part, and on the vertical line we have magnitude of fz, which is a complex function. Okay, and when you will want to rotate, you can do in any direction, and when we rotate at 360, in this side we have is real, and in this side we have imaginary. And when you will do in this way, see these corners, and in the center we have the dark blue. Okay, this will help you to understand the color map also. See the corners, these are the corners on the top according to the height. Okay, so see now. Okay, so when you will observe this graph very carefully, the deepest part will be in the dark blue color. Okay, so as soon as the corners will up, and here this is the light blue highest point. This is not the highest point. Okay, you can check it. So the highest point will be at this point we have 10, and this is 10. But here these are 8 and 8. So as soon as the height will increase, the color will be in blue. Okay, and in the darkest point are the lowest point. You can see this is the absolute graph, and this is the we have phase graph of the same function. And you can study by rotating this diagram in any direction, and will help you to for more understanding, and colors will also help you to understand the values, variation of the function, and many more. Okay, so 3D is very important to understand with the help of these colors also. After that, we have the contour plot. Come here. These are the statement images C. Okay, for the color, and this will extract all the values of x vector. This will extract all the values of y vector, and this is the absolute function. Okay, and we are using here color bar also. Title, magnitude of fz, real x label, y label, and axis xy both are there. Also in the second we have the phase color plot. Okay, this is the phase color plot, and here we are using angle. The other part will same. Control and enter. So here you will observe two graphs are there. So first check this one. So this is the same graph as we saw in the surface. Okay, and you can see these are the corners, and at these corners the values of function will be high. Okay, and the darkest color where you can see the 0 point will lie at its place. So this type of the color mapping will help you how the color variation we can get the function value by using the function value. Okay, the magnitude of fz by using this is the graph by using the magnitude of fz. This is the real part of z, and on the in this side we have imaginary part. Okay, if you want to check the least value of fz, so least value is 0 when the darkest color. So at this point where the dark value, we have the least value of the function, and for the maximum value you can see the yellow color. So this is the yellowest color which you can see, you can observe at this place. This is the highest value which is about 10, and on this corner is also 10, and here the color which you are observing at this point light green yellow color is observing we can at this place. So this is where these values lies between about 8 and 7. Okay, you can compare with the colors. So these are the function values, and similarly you can study this graph which you are observing at this place. So the least value is at this point, and at this point which is the darkest blue, and the fine yellow color showing the highest value at this point and at this point. Okay, so this will help you to understand the highest value. You can see about 3. So by with the help of this color bar you can study easily the value of this function fz. Okay, now come to a vector field. Okay, so here we have the u is real part of w, and v is imaginary part of w. Compute first real and imaginary part component of the function, then we will plot here vector field. Okay, this is we are using qweaver. This is the function, and by using this function we can easily plot the vector field. So here we have x, y, and uv. Title, x label, and y label. When you will plot by control and enter, you can see this is the vector field in this way. And last we have the 3D surface. This is the similar as we do in the first one. So here you can have the real surface, and one is the imaginary surface. So these are the surfaces, and statement are surface function x comma y comma real w, and here we have imaginary, and control and enter. So this is the first graph, and you can see the similar as we do in the very first graph. Okay, and the second one we have is the surface plot of, okay, I need to change, this is the imagery of z. This is the imagery of z. I have to make update at this place. Here is imagery. Okay, now it is fine. Yes, now it is okay. So this is the imagery part of fz. So dear participant, I hope that the content which I try to present here, and I try to discuss several method By using all these technique, you can visualize your function by using the anonymous function, and this is the easiest way to visualize any complex function which you want to study or you want to visualize, but it depends upon your study. Thank you to see this lecture till the end.